So, a pleasure. Thank you. It's a pleasure to present to. The topic is interesting, and I thought, as Dr. Shinu was alluding to, a lot of disruption that all of us are experiencing and thinking. So, what I'll do, my intent in the next half an hour would be to give you a view of a broader perspective of a disruption in a convergence world. I will probably ask you a lot of questions. I know it's not going to be interactive, and like Dr. Shinu mentioned, if it is in person, it'll always be that much more energizing, that much more interactive. But I'll ask you questions. You can just think through. I'll probably, my goal will be to get you thinking in certain specific aspects, and you can always go back and sort of decipher what it means for you, right? Because a disruptive world can be fairly fuzzy, right? If I have to use the right word. And if you maybe let's look at this first part, right? If you look at what has changed in and around you 3 years back and now, right? If you look at every aspect of your life itself, of the way you respond, the way you react, the way you leverage, the way you buy, the way you consume, aspirations, ambitions, right? I'm talking at an individual level itself. You're seeing so many changes to a personality that many a times, if you're coming back to meeting your old friends, they will probably try and figure out this is the same person you're meeting up, right? Same thing with industries, right? Look at manufacturing, look at retail, look at banking. Each of those industry sectors have transformed dramatically over the last 2 to 3 years. A lot of what we looked at as wishful thinking 3 years back from a technology landscape perspective has become need of the hour during and after the pandemic scenarios that we're seeing, right? Let's quickly glimpse. I'll probably spend a bit of time on looking at some of the broader philosophies around how technology itself is evolving, right? And if you see, forget the pandemic itself, right? But if you see the technology evolution from 1900 onwards to 2050, there's so much of the density of innovation in the last 10 years, 12 years, 15 years has really transformed the way we look at technology itself. And you can see this is just an example of how you're seeing what's happening out there. But if you look at the reasons behind it, right? We had the early enterprise apps era, the mainframe era, then the whole cloud concept started picking up in around 2000 timeframes, and affordability came down, scalability went up, elasticity became real. There's so many business parameters and non-functional requirements that became more and more real as we went through that, right? And you can see that, the way we're seeing now, the current state of where AI and some of the other technologies that we'll talk of as we go through are evolving. This particular forecast says that you can create an artificial brain by 2047 or 2050, right? Now, I'm not too worried about the ethics and let's not get into the social aspects of technology, right? That can be a different topic for discussion. Let's stay purely focused on technology itself and what it can do, right? Artificial brain by 2050, singularity as a concept, and you're tending towards that, right? And that's where the whole idea of convergence becomes very, very important, right? This is a slide for you to just think through. You can always research this slide a lot more in detail. Each of those concepts, whether it's VR enhancing drugs, you're talking about virtual reality windows, virtual holidays, all of these are today becoming more and more real, right? In the current digital mirrors, sensory internet, right? 3D gaming, this announcement of cloud providers now giving gaming tech features on their cloud platforms, very soon now, right? So you can see a lot of those things becoming more and more real. Let's look at some aspects of it, right? Now, if you look at all that we're seeing today, and that's why this 1900 to 2050 landscape becomes important, because if you see many of those things that are in 2050 there would have been in some form picturized or visualized in a movie, and we can see a good example of how we've seen fiction to reality over the last couple of years, and the density and the speed of innovation is reflected very strongly. Right? Look at a video phone in Metropolis 1926. It took almost about 80 years. Skype made it real in 2006. Right? Look at a driverless car, Minority Report 2001. In about 10 years, you test drove the first autonomous car on the road. Right? So from 80 years, you've shrunk fiction and made it more real in about 10 years time frames. And that's a very important dimension for many of us to think about technology, right? Because today, when you look back at technology, it's no longer you solve the technology problem first, especially in the last 2 years, 3 years. We've seen that problems were created or situations had to be resolved, and then technology was then adapted to solve those problems. Whether it's going to be the pandemic, lockdowns, isolations, masks, vaccine itself was such a huge transformation, the way technology has evolved in the last 3 years. And that's going to be bigger and more pronounced in the going years, right? So the shrinking cycles are important. Shrinking cycles are leading to a lot more opportunities for many of you out there. If you're sitting and looking at this as a world, I think if I look at a 5-year window from now to 2025 or 27 and 27 to 30 or 32, most probably you will see a different world. Right? To what extent is a futurist thinking? We can keep debating that. A very interesting debate for a lot of you to have coffee table discussions with your friends when you're sitting in canteens and looking at a few things. Let's blend further a little bit. Right now, we're looking at a lot of things are changing with the way we said, and technology is no longer complex the way it is, and we're seeing that in our world today. Right? Using technology today and doing a virtual conference like this. And many of you are physical, but you could probably not have imagined a video conference like this across multiple stakeholders across a geography on a single axis frame the way we're doing it right now, right? So, and it's fairly intuitive today. I think anybody can get onto a Teams call or a Zoom call like this and be as productive as they could have been when they were in the physical world, right? Important dimension to again think through, because simplicity is driving the edge a lot more strongly today, right? And the digital native behavior becomes very important. You can always go back and look at people who were born digital, people who were born after 2000 or 2005 or 2006. The way they see the world, the way they see see technologies, the way they see consumption as a habit has drastically been disrupted. Right, and it's important dimension because I think this generation of people are going to be into the prime going forward, right? And iPhone, iPad, smartphones, kids with 5 years, 6 years will just start using it with nobody necessarily having to teach them or take them through a course of how to use it, right? And that is becoming a rampant behavior. So you'll see a lot of expectations that the machine should understand me and respond to the way I am reacting or trying to use it, rather than me trying to go through a manual and understand that. And this can move also when you look at complex operations tech and engineering tech in factories and outer spaces, and it can get far more complex, right? So if you look at skills that are required, right, when you look at digital native behaviors, a lot of us are thinking digital first and then looking at the physical world. Problem solving areas will change. Critical thinking becomes very important. Innovation becomes prime. Creative vision becomes very, very important, right? And these the whole idea of collaborative and communicative work styles become very, very important, right? And as we look at the skills, what will also be important for us to remember is the central pillar, right? Look at integrated business tech themes, right? These are convergence. You look at human augmented machine intelligence, you're talking of a man and a machine working seamlessly with no boundaries, right? And it's getting real. You can see that in many other areas, cobots being real, surgical robots being more and more real, right? And then you'll see that we'll talk a little bit more as we go through into that. Mechatronics, intelligent mechatronics is becoming very, very important today, right? The more you see empowered edge, you'll see mechatronics becoming a lot more, because the way you acquire data, the way you process data, the way you make decisions, the way you correlate and contextualize information systems, all happening at scale at the edge, will be very, very important in the new world that we're looking at. Simulation and modeling becomes very important because in the digital world, your concept to reality probably is not even 11, 10 years. It could be 10 seconds, right? I can just go to I'll use a metaverse for any other, go to a digital world, drag and drop a few things, place them into a particular business process, click a button, and I can execute that. It may not be 10 seconds, but maybe 10 minutes, right? So concept to reality can shrink to as low as 10 minutes. And that integrated approach to simulation and modeling where I'm sure the leaders talking about cybersecurity, about safety, about privacy, ethics, all of those things become very important as you go through in a digital world. And then, the whole world of augmented virtuality, because many of you, I'll not go into details of the technology landscape in this session right now, but I'll give you a broad overview of how you should be looking at it and where you should be researching and trying to understand and ideate and visualize and conceptualize in your minds, right? But imagine a room which is completely digitally empowered. All four sides of the wall are screens which are stereoscopic with 3D content, and you're interacting with factories and outer spaces and oil rigs and smart cities and all of that, right? Now, that is just the approach of simulation modeling that we're talking of. You go into a smart city in the digital world, interact with it, you process it, and then you can transform that back into the physical world, and that can be all seamlessly done there, right? Now, what is important, and a lot of you here with, I saw an average of 3 to 15 years experience from a technology footprint perspective. The complexity is for people who are creating technology, right? While we said simplicity, we said, business solution architecting, BizTech themes, techno-functional areas, right? The complexity that you look at when you look at teachable machines, train an ML model, do explainability in models, look at transfer learning, model compressions. Those are far more complex to do, and your window to complete that is no longer 10 years, 15 years. They probably are a couple of weeks, couple of months, and that's where you'll see a lot of skill development that's required, right? And that disruptive world that we're talking about here is effectively coming from that perspective, right? Looking at making anything anywhere digitally experienceable, right? Now, whether it's factories, it is oil and gas, it's EV, whether it is apparel or medicines or telemedicines or surgicals, right? The digital aspect has become important, and it's only going to go on more and more important. It has a far-reaching effect on bigger topics, whether it's going to be circular economies, transition economies, the sustainable thinking part, right? Environmental friendly. Many of those things will start getting more and more real as you see these digitally experienceable spaces, concepts, and design becoming more and more real. This is so exciting. Yeah, you look at the whole integrated business tech themes. You blend skills, you blend technology, and then you take the process or the industry itself at the core and see how that is disrupting to make all of this come together in a very seamless fashion, right? Let's move on. Very quick glimpse. I'm not going to spend again time on this. This is something that you can easily Google and get a lot more information that you're looking at. Many of you will be studying a lot of these topics within your curriculum in the coming years, right? But each of these elements I'm talking of here are making a fundamental shift in the current context. Right? You're moving towards general intelligence. You're moving towards a very powerful explainability aspects where you're looking at democratizing AI or democratizing skills or knowledge to such an extent that somebody who's not necessarily an expert can use it, make decisions which are stable, which are sustainable, which are resilient, and work in that world out there, right? Software-defined intelligence, software-defined machineries out there. Robots can actually perform cognitive tasks, hopefully in the next cycle that we're looking at, self-learning and ambidextrous robots we're talking of. You're talking of digital trust. You're talking of things transacting with things, businesses transacting with businesses with no human in the loop out there. So digital trust becomes very, very important. Software-defined trust will drive a lot of the world that we're looking at eventually. Software-defined experiences, all the way from looking at computable experiences where I can actually compute an emotion, compute an a touch aspect, compute a gesture, compute expression, and be able to assist it, guide it, or make inferences basis those computable environments that we're talking of. Fairly powerful, fairly doable today. Computable assets or software-defined assets, the whole idea of IoT ecosystems, and 3D printing into the 5G world where you're looking software-defined networks itself out here. So fairly, one thing is becoming clear on the technology landscape. A lot of it is moving from hard-coded environments to computable environments, to software-defined environments, right? And that is all technology out there. So if you are a technology person sitting in your chair today and looking at what is the opportunity for you out there, I think it's a world of opportunity out there, right? Blending all of these, each of these individually, collectively, and then trying to sort of conceptualize how this can transform into a world which is moving from smart to intelligent. We saw last couple of years, everything was smart, smartphones, smart factory, smart city, right? These technologies, the way you're seeing it, the way they are converging this behavior with industry, with technology, and multiple emerging areas out here, you can start defining an intelligent enterprise, right? And that's a fairly transformational thinking that you can look at. Smart to intelligence is a very, very powerful journey. Many of the things I'm talking of right now are not done today, but they are in the roadmap. You'll start seeing them happening in the next couple of years. Very quick view again. If you look at transformational concepts out here, human augmented machine intelligence in a smart factory where you can have humans and machines can be physical, co-located in a world. It can be hybrid where the human is remote and the machine or robo is in the factory, and you're able to do security checks, you're able to do quality checks, you're able to make on-the-spot cognitive decisions on production capacity, on quality of raw materials. Practically every KPI that's getting captured on the smart factory, you can see humans and machines working together in real time and improve efficiencies, improve sustainability, improve environmental carbon footprints. Many of those aspects can be visualized fairly powerfully looking at this technology stack out here. You're looking at retail. You're blending you're practically blurring the line between physical and digital world in the retail. The only area where in the retail world today you cannot really establish an experience is a physical touch or the haptic aspect of it, which is also doable, but it's not at scale that we need to get it at a cost and the scale benefits that are needed there. But every other aspect, whether it's virtual try-ons, avatars wearing dresses for you in the metaverse and showing you how it looks, creating mood settings, creating occlusions around the dress and seeing how, if I walk in a particular path, how will it look? All of those elements are today doable in the virtual world. So you can practically bring a showroom, an apparel showroom into your living room. You can actually use AR to do body measurements. You can use computer vision techniques to look for the best fit. Use GAN for designing actual style formats and designs patterns that you're looking for. Go ahead and maybe 3D print it eventually at some point of time, or you could go and buy it online. These are worlds which are very real today, and you'll see amount of dematerialization happening through some of these processes at very, very intense levels. Simulations, we spoke of a lot of simulation in the earlier world where you can actually plan for a complete strategy in the virtual world and transform the strategy from the virtual world or simulated environment, which is fully immersive, to a physical world, maybe at a click of a button, right? Not sci-fi anymore. You could visualize that happening. Many of us are seeing some of those elements in the surroundings today. Smart city again, green corridors for ambulance, the whole idea of how you optimize for efficiency and comfort and experience all at the same time, and get more real time with your analysis and decision making. Distributed decision-making systems and AI systems in a smart city world become very, very important, right? Because the dynamics of change is extremely high. What can change? What is needed? How things will have to adapt to what's happening out there can be fairly dynamic as you see a smart city with a IoT, AI, blockchain, digital twin, 5G, XR world, right? Internet of skills and experience again, where you can look at using skills and transfer skills across two entities using tech platforms. You can transfer Experiences also, we spoke of that in the augmented virtuality world also, right? So fairly like the internet, which was used in the past to transform or share data, you can transform skills or share skills, and you can share experiences also. And that's an interesting dimension that we're looking at. Very quick functional view of the whole area. I'll just introduce one concept, and I want a lot of you to think through some of these areas. We've spoken of the IT OT world so far, right? They're converging. We're getting better productivity. We're getting better efficiency, right? The information technology, the operations technology world is fairly converged. We're seeing some solutions like field assist, expert assist coming out of that space out there. The moment you bring in the engineering tech behind it, you move from historical data processing in the IT OT world to a real-time data processing, right? Where actually I can go back and use the engineering data to define and see whether a particular gear is damaged by zero point 0.1 micron, right? What use cases? There are many that you can go back and think through. But the moment you converge engineering data with operations data, go into predictive maintenance, converge it back with your IT data, you can look at a very powerful condition-based monitoring environments, whether it's humans, whether it's machines, whether it is factories, smart spaces, all of those environments can be looked at far more powerfully. Flip it further to industrial gaming tech, where you can use gaming technologies to converge IT, OT, and ET data into a fairly computable world. You're talking of actually computable environments out here, right? You can use this environment to practically control anything from anywhere without physically being in that space there. And whether it's oil rigs are in the middle of a ocean and running into hundreds of acres, and you can't have everybody on the rig at the same time. You can get into far more efficient ways of monitoring and operating rigs in that format. Right? There are other areas you can always look at. The other spaces like horizontal focus areas. We're looking at cloud, low-code app platform, distributed cloud, model compressions, edge AIs. Right? These are important areas. Look at the others I mentioned. We're looking at the emerging areas. Talk of generative designs. This is not necessarily emerging. I've used the emerging to just differentiate between what is mature and what is being experimented today, right? Autonomous systems, additive manufacturing. These are areas that you can see converging and driving a lot more efficiency for us in the process here, right? I'll probably take one more slide and I will open it for Q&A. I know we are on the hour from a presentation standpoint, but look at this more from all that we've looked at so far. We've talked of computable environment. We've talked of, I'm not going to defining what metaverse is. There's no defined definition. Everybody has their own version of it, right? It is a buzzword right now. A lot of things are happening around it. But I'll just give you a fairly conceptual framework of how to look at metaverse, right? Web 3.0 social existence to the whole idea of DAOs, looking at how avatars, digital twins, 3D commerce, content creation, the NFT part blend back into that space with virtual economies coming in there. Of course, the non-functional areas becoming very, very important out there, right? That ecosystem is something that can transform a lot of the way we see the world today, and it is growing really very fast. Now, how quickly, how soon, how much, how positively, these are things that probably will not get answered immediately. It will take some time for systems to evolve, for technologies to converge, to mature, and then start realizing that ecosystem. But that's a journey that we see happen very rapidly in the last 6 to 8 months, and will move at much rapid pace going forward. The technology itself, right? We've seen hardware and infrastructure itself evolve and dramatically transform the way we're seeing technology, network with 5G and communications becoming almost near zero latency and near zero response times. You're seeing a lot more happening there. And a lot more will happen with 5G getting more real, getting more scale mode in the next coming months and years, right? Edge computing and cloud computing and computing at the edge with cloud is becoming important out there. You're seeing that becoming more real. Decentralized systems, whether it's blockchain plus distributed systems with various layers of concepts, becoming very, very real today. And that entire tech stack, I think tech stack is I've just put some important ones out here. You can definitely add a lot more to it. Immersive experiences, interactivity through AR, through VR, through room scale VR technologies, through something called computer augmented virtual environments, industrial holograms, right? That world is moving fairly smooth, and we can see a lot more happening out there. Extended reality, blending that back into the back end of the technology there, virtual environments, robotics, IoT, 5G coming in under one bucket to realize some of these things. Blockchain, making data immutable, making data fungible, and making data valuable for through privacy, through virtual economies becomes very, very interesting from that concept there. AI, ML, again, transforming the entire landscape out there. Each of these coming together with AI, ML can give you a far more interesting spectrum there. I think I'll pause. I'll end my session here. I'll only, end with a few areas of, how we could leverage this. The whole idea of experimentation, development, life cycle, the whole culture. See, culture of innovation becomes very important when I look at some of these areas out here, right? Because the whole, a lot of technology folks think of not invented here syndrome as a major driver for their career growth, and that's the worst thing we could do as technologists today in this world, right? The whole idea of open innovation, crowdsourcing, cross leveraging, collaborating becomes a very, very important culture that we need to look at, build, nurture, grow on, right? Second, the whole idea around fail fast and succeed early. As technologists, we are used to holding on to a technology or a solution or an asset or a stack so closely to our heart that we fail to see that, the changes that are required to make it work, right? So the whole area around being able to see the difference, see the changes, and adapt to it becomes important. Third element, the fail fast, succeed early is very, very important, right? The moment you start failing faster, you'll start seeing that you can actually make those corrections and succeed faster. Third is creating an ecosystem around you. And I think Dr. Shinu also alluded very strongly to mentors who are already there in your system out there, right? So how do you create an ecosystem of mentors, of technologists, of business experts, domain experts, of thought leaders, of futurist thinkers, of doers, of coders, right? Each one has, his own ecosystem. You'll be able to see and drive a lot of these. And this is true for individuals, for enterprises, for corporates, for businesses also, right? So looking at creating an ecosystem and driving that becomes a fairly important aspect. And the last element I want to just allude to is learn fast, right? Because agile mode of learning, the whole idea of experimentation-led thinking and learning, learn, do, act, and learn very quickly again. And I have seen people in my teams, in my surroundings, learn a new technology, a new coding language in 3 to 4 days, and get into production mode there. I've also seen a person in a hackathon who learned the technology in 5 hours and started working on the hackathon there, right? So I'm not putting pressure on you right now. Don't get pressurized by that, right? But I'm saying ability to learn very quickly, to digest very quickly, and conceptualize and transform it becomes a very important aspect. I'll pause, open it for questions, and happy to stop sharing so I can see the screen also.
Yeah. Hi, Pravin. I have one question. Like, how cloud plays important role in all these technologies?
See, cloud is a hygiene, right? Because the moment you say data democracy, skill democracy, and experience democracy, you're looking at data. All the culture aspects that we spoke of are all driven by cloud. Fail fast, succeed early is rapid, to implement the whole crowdsourcing elements where you can actually create in a collective world, and everything that needs to get distributed needs to go to the cloud. So cloud becomes fundamental. I think there's no whether it is what type of cloud doesn't matter. Hybrid cloud, private cloud, multi-cloud strategies, all of those will become important. The more multi-cloud it starts becoming, the more important for you to realize how important cloud is, right? Because there were earlier, I know when I started looking at cloud about 10, 11 years back, there was so much of limitation on migrating into a cloud, right? There were no standards. It was very difficult to take something from on-prem to put it onto cloud. It needed a lot of engineering. Today, at a click of button, you can deploy things in the cloud. You can spawn a cloud in probably one-click button. You can deploy something on that in one click, and you can scale everything in one click, right? So I would say any of you doing anything in this technology world, by default, cloud becomes a minimal entry point for you from a technology standpoint. If you are not familiarized with cloud, if you can't drive cloud, you can forget doing any innovation work out there.
Okay, well, thank you.
Hi, I'm Mohit. I have a question. It's like, can you give us some tips? How can we learn a new skill faster, technically faster? As it's very important.
Yeah, Mohit, you know what? Today, there's so much content available for you to learn. It is not like 10 years back where everything was very confidential, and you did not have access to things. I don't think any of you will have a problem whether it's looking at any of the online courses available out there, collaborating on some of the blogs, the technology blogs out there, reading thought leadership. See, I think it's important to understand the big picture before you start looking at actual coding areas. A lot of us are good at doing certain tasks, and we focus only on that aspect, right? Learning Python is not everything. Learning Python with explainability, learning Python with some of the neural networks out there, whether it's RNNs, CNNs, learning Python with GAN, right, and translating that back with a business model, business process, translating that back with an experience, is where you will start seeing the big picture thinking evolve, and then you can get down to learning some of those smaller things out there. It's all about a decision. I don't see any challenge for anyone to learn any new skill at any point of time, be it robotics, drones, be it most of these open source. See, one good part we've seen in the last 5-10 years is a lot of open source consortiums have started becoming more and more real. They've started becoming more and more, whether it's 3i, the whole area around OpenGL, from concepts there. Blockchain itself is fairly open sourced. The GPT-3 is fairly open sourced. So I don't think you should worry about how. It's about accessing and learn more. You'll probably learn 10 things. Not all of that is going to be very valuable to you, but your ability to process information after learning those 10 things will be much higher, much better. Right? I would probably leave it at that point, Mohit. But now that you're thinking about it, I'm sure you'll find a way to go and learn faster, learn more.
Yeah, well, sometimes it's like very overwhelming. Everything is coming, so that's why I ask.
Yeah, no, once you get started, it should not be too difficult. Yeah, it's all passion. You know what? I would put passion first, then learning next. Right? If you're passionate about learning something new, you will figure out a way of doing it. LinkedIn is a good source for learning also, right? Whether it's LinkedIn, whether it is you talking to mentors on LinkedIn, you reach out to people on LinkedIn. Any of the mentors within the institution or people on LinkedIn will be more than happy to guide you on specific questions and areas that you want to guidance on. Reach out. I mean, my only suggestion would reach out more.
Okay, thanks a lot.
Hi Pravin, this is Rudradeep here.
Hi Rudradeep.
So first of all, hi Pravin. First of all, I wanted to thank you to take your time and give wonderful keynotes. Thank you for that. I have a question. So if somebody are continuously on technology or technical stuff, how they can innovate the things until and unless they know how to do market research, how to do user research, and so on and so forth. That is also very much important, right? Because if I want to innovate something, but first of all, I have to see what is the problem. That I have to find out. And then if there is a problem, then what is the market? What user wants? Until unless I know that thing specifically, then technology, there is no value of technology, right? So how do you give us feedback about that?
Yeah, so you know what, again, I'll go back to culture, Rututi, because first is a problem space, right? Obviously, I think you start anything with a well-defined problem, scope the problem, and the earlier world of there being a BA translating the problem to a document, and you picking up a document and then trying to put a architecture behind the document and then building it up, that cycle is dead. Believe me, that cycle probably will never help you learn and grow and do things out there, right? So being closer to the problem space is important, and you said it rightly, right? Then you try different technologies, and that's where the whole idea of fail fast, succeed. I'm talking of pure innovation. Modeled problems, I don't think there'll be a problem. If anything is modeled and defined and process driven, there's no issue at all. You can go the agile methodology way and do it. But the moment you look at innovation and solving unsolved problems, you will need to get into the experimentation development life cycles, right? And I can give you a very quick tip of how we thought through when we are looking at it. Looked at 4 layers. Looked at a proto, looked at a hack. A proto is a business problem trying to be solved, and apply any technology, current, past, future technology to solve the business problem. Look at a hack where you look at technology problem, look at any industry process out there and see how you can fit that problem to solve that thing in that space out there. Couple of protos and hacks will help you build a plot, which will be a single process, a narrow area that you can go and experiment and try and see how the system works. And once you get it working in a plot mode, you can go into a thematic mode and roll it across an industry process. Right? Innovation will need to be done in a very systematic way. You have to ensure that you're converting innovation from a fuzzy environment world to a more scientific way of doing things. Culture becomes important. Very, very strong habits become very important. A very strong learning curve becomes very important. Collaboration becomes important. Crowdsourcing becomes important. Open innovation becomes very important. I would put all of that together and try and make it work. It is not something that you can do it individually. It has to be a team. It has to be a fairly well oiled engine coming together to do big innovation. Small ones, you can always try yourself.
That's right. Yeah. And one more thing is product management versus maybe artificial intelligence in MTech or maybe business analytics, whatever. So if somebody has interest on business analytics, should he or she first go and learn product management, at least not the very broader way, at least somewhat, then he might get somewhat dimension to innovate and then probably learn and may apply business analytics?
See, I would say product management will be important for any of you, but I don't think it needs a certified product management course for you. But you need to use product management thinking through the process of doing what you're doing.
Okay.
Right? Functional, non-functional, the whole idea of response times, the whole idea of how do you look at latencies. Those become very important in overall thinking also. The roadmap, defining feature functionality roadmaps, technology feature functional roadmaps, the cost economics part of managing the cycle, agile methodologies. All of those become very easy. It's important for you to understand. I would not say you need a certified degree behind it, but product management becomes a very important aspect of innovation. Otherwise, you'll end up missing out on your ability to reboot yourself becomes restricted if you don't understand product management well. I would leave it at that point.
Okay. Got it. Thank you so much. Thanks for your explanation. It helped really. Thank you.
Hi, Pravin. Can I ask the question?
Sure, please go ahead.
Thank you so much for being kind and listening. The thing is, just now you had spoken about the BA process, right? For example, understanding the requirement of the user and then building those documents which helps the architect to build the ERP. So I'm kind of into that role. Now, as you rightly said, this it is getting outdated. How will I transform from that by gaining these knowledges? Because I feel that will only be completely outdated when a developer or architect is into that product for long time. If the person keeps changing, then still there is a validity of functional BA being there. So if suppose I have to transform, then how these skills will help? If you can just give an idea, that'll be very helpful.
So, Arif, if you're saying, does BA have a role, or how do you transform a BA's functionality into your? Where is your question coming from? I'm trying to don't answer the wrong.
By adding these skills, which is the AI and all these Azure related skills, how will I transform and help an organization? But by just not sticking into a BA, how will I transform myself is the question.
Okay, from an enterprise point, Arif, you know what? If you look back at all that is happening out there, you're practically going from historical or post-mortem data to everything happening in real time today, right? And that's one reason why the conventional ways of doing things will not suffice, and that's why we're seeing that world fairly getting disrupted very fast. Right now, volumes are different, scales are different. Monolithic architectures will not solve the problem, right? So the whole idea of observability platforms, the whole idea of CI/CD, DevOps worlds will start of will start driving a lot more of these towards success, right? Microservices architectures, event-driven architectures, all of that will start becoming more and more important, Arif, right? So how you need to also keep, so it's a T-shaped skill, right? I mean, if you look at all the skill development we spoke of earlier, creative side and all of that, right? It's a T-shape. You need to be aware of every other technology stack out there and be an expert in one big area, right? Think of it that way. You need to know architecture to some extent. You need to know BA to some extent. You need to know experience, UX, customer journey to some extent. You need to understand cloud. You need to understand mobility. You need to understand social behavioral aspects, right? And then you pick up one. It could be AI. It could be smart app development. It could be observability areas. It could be anything, right? Then you'll start looking at it. I'm giving you a picture of too much of dimensions into what I'm telling you right now here, but pick up what works well for you and build on that, Arif. I would leave it at that, because the more you try and do, the more difficult it can get. But it's good to build it over the next 3-year, 5-year window, right? Give time to learn something new. Every 3 months, learn something new. Not necessarily from a work definition perspective, maybe from a hobby perspective, right? Whether it's observability areas, DevOps, microservices architectures, event-driven architectures. Take TOGAF and blend it back into what you're thinking out here, right? Keep learning new without necessarily an end goal in mind. It'll probably help you think better, think more wider in terms of concepts there.
Yeah. Thanks, Pravin.
Is that okay, Arif?
Yeah, that's fine.
Okay, perfect.